a really great opportunity. So yeah, just start right in. Portland, my name's Paul Bradbury, and I'm airport director at the Portland Jetport. I've been here for a long time. I won't go how long unless somebody asks a question at the end. So with that, I'll jump right in. Thank you for the opportunity, Troy and the Portland Sustainability team. It's great. I appreciate it. So jumping right in, just very briefly, couple informational slides. Yeah, we are Maine's largest airport by volume, not size, just a small 769 acres. We're a designated small hub of 2.2 million total passengers that we serve annually. And we're located just about 3 miles west of downtown Portland and have some great connectivity. But if you look at this map, we are bounded by several. We have the Fore River to the north, Long Creek to the south, I-295 to the east, and Maine Turnpike to the west. So we're pretty boxed in, as are most airports in the Northeast. With that, it's been really exceptional. We have a lot of exceptional air service for Portland for a metropolitan statistical area, MSA, of just over 520,000. We really are outsized in our ability to connect to the world through aviation, which is great to see, with a lot of carriers and significant nonstop service. And just recently announced that Denver is going to go year round on United. So that's some great news. So really connecting our region not only to the U.S. air transportation system, but to the world in all the major carriers, and likely more surprising to me than most, but with 3 ultra low cost carriers now: Breeze, Frontier, and Sun Country. So really impressive that way. Just to hit really briefly, this is 2012 to 2023, and it shows highlighted all-time record passenger volume months. So what you can see here is that in 2023, we indeed hit an all-time record of 1.109 million boardings. So that's an enplanement or a person getting on an aircraft out of Portland, and hit all-time records for June, July, August, September, and October in 2023, which made up for a less than stellar first quarter, which you can see kind of some of these red numbers over to the left-hand side. So made up for all that and still came in with a record year, up 1.4% actually over the prior record of 2019. So just to give you a little bit of where the passenger volumes are. And here's a interesting chart that whenever I talk about aviation in Portland, I like to show. What's happened is, back in 1997, we peaked on our number of takeoff and landings out of the Jetport at nearly 129,000 takeoff and landings, yet we only had in total passengers. So what this chart is showing is passengers getting on and off an airplane. So we only had 1.2 million passengers way back then in 1997, and now we're over 2.2 million. But our number of takeoff and landings has gone from nearly 130,000 down to just under 54,000. And everybody can say, wow, how is that possible, that we're doing so many more passengers on so many fewer flights? And the answer is planes have become much bigger for our market. It's called the upgauging of aviation. So we have fewer larger aircraft, A320s and 737s, which are much quieter and much more fuel efficient, carrying way more people than they did back in 1997, when we may have had 30 and 50 seat aircraft that simply don't exist anymore. So now much more fuel efficient. And in that earlier chart, I won't go back, but very high load factor. So the planes are very full. In fact, for a couple of those record months, we were over 90% full on all of our flights on average. So you can just imagine how full these planes are. So with that, I want to jump right into the sustainability. So this is, let's go back in the past. It doesn't seem possible to me, but it's been over a decade since we welcomed the terminal expansion that was completed in 2012. It did achieve LEED Gold, and it was the second in the country, right after San Francisco, that was for an airport to achieve LEED Gold. And we're like, darn, we just missed it. So hoping to be first, but we just missed it. San Francisco beat us out. Kind of interesting here is just to see the rendering versus actual. So they looked very, very close. Amazing how good the renderings are and how close it actually came out. So moving along, one of the things that got the terminal to achieve LEED Gold was a geothermal system that we were able to do during construction, make a quick turn, and with some help from a program with FAA and that Congress worked through the FAA grant program. It was called a Voluntary Airport Low Emissions Grant, or VAIL grant, helped us to fund, and we did it kind of midstream during construction, but a geothermal system. So here, let me just bring these all up. So from the terminal that in this picture was under construction, we brought 10-inch underground lines all the way to a bore field, which is under what is now, and you'll see in later images, our employee parking lot. So it's, I believe it is still the largest in Maine of a closed loop system. So it has 120 wells drilled 500 feet deep and nearly 23 miles of pipe, and it does heat. So here's a heating kind of view that we take, thermal energy, and it's just the ground temperature being 50 degrees, and a little more on that in just a second. Outside temperature in the winter of 10 degrees. We're taking thermal energy from the ground and just using a heat pump, kind of the reverse process of your refrigerator at home, and moving that thermal energy into the building. And in the summer, we do the reverse. We take the heat out of the building and transfer it to the ground. And those wells, if you look at an air-cooled engine that has cooling fins, those closed loop wells are really just cooling fins in a way drilled down into the earth, 500 feet down and back in the pipes. So we're not taking water out of the ground or putting water back into the ground. It is closed loop. So those pipes are really just thermal energy transfer fins into the ground, which, we can say is a roughly average 50-degree ground temperature. But the reality is that it varies. And we do, by the end of our heating system, or our cooling year, this temperature is down around 38 degrees when we start air conditioning in the summer. So we actually are getting 38-degree water out of our bore field when we start our first air conditioning, often in late April. We'll have one of those warm days and be starting to air condition, and we'll be taking really cold water and really have to do nothing to no compression to start cooling the building. And then obviously the reverse process, by the end of the summer, this ground temperature is actually up to around 78 degrees when we start heating, almost a good enough temperature to put right into the warm floor system. So this is just a couple pictures of that construction, the manifold vault, all of these pipes going out to the individual wells. Well drilling, it is the same kind of drilling rigs that are used for artesian wells throughout Maine. So it was a great application here. We had multiple well drillers going for a long time back during construction. And then part of how we put the heat into the building isn't through high temperature, because you don't want to have to do more energy to get a really high temperature. So using a low temp radiant floor, 90 degrees, we can, and this is through all of those concrete floors throughout the expanded terminal, is how we transfer that energy into the building and heat the building. So shifting gears, and I want to make sure I have enough time for questions. I wanted to hit the next project that came around, which was our solar project of just under 30,000 square feet. And it's actually, I kind of put a yellow line here. Maybe I should have made it more bold and surrounded it. But it's up on the top level, level 5 of our parking garage, which is just under 2,000 cars of capacity. We have nearly 30,000 square feet of photovoltaics, and they generate can generate 575,000 kilowatt hours annual. So that's just straight kilowatt hours. And it's actually much higher than that. It's the output is 235 kilowatts in real time. So saves about $86,000 annually in electrical costs. We funded this one with Section 512 money, so it worked very well. Again, with some airport improvement program. Again, another FAA grant helped us to make that happen. And I'm really pleased that FAA has been very supportive of sustainability projects. And actually, I looked at that wrong. So it's, so that would be the equivalent of 575 megawatt hours annually. Then trying to move and make sure I have plenty of time for questions. So I wanted to switch to our next topic of sustainability, and that is our aircraft de-icing fluid capture. This is the original de-icing pad that we had built back in 2010. In another slide, you'll see it's growing. But what we do now, we used to de-ice our aircraft at the gates. So when an aircraft was at the gate, it would be de-iced. That we use the aircraft de-icing fluid is a propylene glycol. It's non-toxic, but when it's discharged into the environment, it does take a high amount of oxygen to dissolve. So it has a biological oxygen demand. If it's in any stormwater, it will absorb oxygen out of that water. So if you're pushing into a small tributary, it would absorb oxygen that would otherwise be used for fish and other aquatic life. So the idea here was to capture it. So we have this central de-icing pad that's all pitched to drains that then go to a valve box that we can then transfer into a 500,000 gallon underground tank. It's actually a multi-chambered cast-in-place underground tank that has roughly 250,000 gallon chambers. And then we constructed this processing building here, which is staffed and designed by Inland Technologies, the process, which is our partner in this. As we moved along, I'll go down through kind of the timeline. So that was in 2010. The system included 3 glycol concentrators, which take this kind of feed from the apron, cleans it, and gets it to a 40 to 50% fluid. Then it uses that we install later, but a distillation system to go from 50% up to a final 99% pure glycol product. And originally we were just selling back as a commodity in kind of the industrial propylene glycol market. So we were capturing it, recycling it, and selling it on the standard market as an industrial propylene glycol that can go into anything, antifreezes, hydronic fluid, for like our warm floor or snow melt systems. But that wasn't creating the value that we were looking for. It's kind of like, having wood pulp as opposed to a finished chair. So we wanted to go for the finished chair, which is the final ADF. So in 2016, we expanded the facility, added blending equipment, and Inland Technologies was able to issue and sell for the first time an ADF, aircraft de-icing fluid, completely FAA certified and produced on site, meeting all FAA's requirements and able to be resprayed on planes right here at the airport. And now we're accepting fluid from other airports throughout the region, as far down as DCA. So we're collecting their fluid and spraying our planes here. And we're also reselling ADF, and we've supplied that to Bangor and other airports throughout the region. This is now the facility as it stands today, multiple pads. This blue line that you can see if you look on Google Earth shows the containment area where we collect and capture all this fluid. It shows, you can see the Inland Technologies from the aerial view here and our existing gates. Again, we used to just de-ice at the gates and it would just go into the normal storm drains. No longer, not since that early time way back in 2010. So with that, out of that came, even today, we remain the only one, but Denver is nearly there. And Inland Technologies our vendor here is now doing Denver International Airport's process, and they are on track to be doing the same thing that we were able to do many years ago now, back in 2016. And then you can see we did receive a number of awards and had very good press. And it's really surprising to me, and it's probably because the EPA still has not required this to happen. ADF capture is still not required under the Environmental Protection and agency. So still, even today, many airports do not collect and capture their fluid. But in time, this is where the industry is going, and they will. Oops. So wanted to say, so really great this past spring of 2023, for the first time ever, we started electrifying our ground service equipment fleet with a partnership with United Airlines. What you see here is down in the bottom left corner is our first electric pushback tug. You can see it's really low. It's kind of wide. That has a nice room for a lot of battery packs. And what I'll say is that the profile of our market, because we're really busy first thing in the morning, our first flight out at about 5:20 a.m. all the way to 7:30 a.m. So a big 2-hour push, but then our GSE equipment can be plugged in until the next big rush that starts to build around 10 a.m. So we have these nice discrete times of day, which the load profile is very good for electric ground service pushback equipment and tugs. But this is our first one, and it's right down at gate 2. And then you can see here a picture of a normal tug, and you can even, if you look carefully, that's a diesel fuel sticker, diesel fuel only. So that's the alternative, is they're all either, the pushback tugs are majority diesel, with some of our smaller GSE bag carts are also just unleaded gasoline. So another thing that is really exciting for me coming right up is the replacement of passenger boarding bridges 3, 4, 5, 6, and 7. What we'll be doing is changing these out from the existing bridges that do have ground power, but what they do not have, which you can plug the airplane in, but what we don't have the capacity to do currently is plug their conditioned air. So that's air conditioning in the summer, and more importantly for us here in Maine is heating in the winter. So what that is done by now is diesel and gasoline powered ground conditioned air carts, which look like this. And inside them is this big engine. So they can produce electricity, but they also can heat. And you can see what this is a big duct that then hooks up to the plane and provides either air conditioning or heating to the aircraft. Those new passenger boarding bridges will have this, and we're hoping to, if not to our central, possibly even our geothermal system, if not to that, they will be electric heat pumps. So we'll be able to air condition and heat the planes with electric heat pumps tied to the existing passenger boarding bridges. So it'll be a great, we now have, if you look, we have gates basically 1 through 13, but we've labeled that 13 as a 14. In the future, it will actually be renumbered 13. We're not that superstitious, but we're looking to make that move so that every gate will have conditioned air. But in the initial rollout, it will be these first 5. So this is already funded, and we're already in design for this passenger boarding bridge replacement, which is just a huge next step in the electrification of ground service equipment. The last project, which is just starting out, and this is the end. I hope I haven't PowerPointed you to death, but it's a battery storage project. So we're proposing, and it's going to be up here in the near what we're working on is another parking project, but we will have their roughly tractor trailer sized battery. So the trailer, it will be 2 of them, but a 1.9 megawatt 5 megawatt hour behind the meter lithium ion storage. So what it will back up is that this portion of the terminal building that was the brand new terminal delivered in 2012 will fully have this backup battery system, and it will do a couple things. So I say backup because it will help us with resiliency. If the power goes out, that entire 160,000 section of the building that is the geothermal heated and cooled section will be backed up with this battery system. But on the sustainability side, a more important component of this is that during the peak hours of the peak days of the year, we will be able to go off grid for a significant load for a couple hours to save reduce the grid's total load, which means we won't have to have, if more and more entities start to do these, we won't have to have those real time. Right now, they tend to be natural gas, quick uploading power plants that have to be available, that are built and available and here and exist year round, but are really peak load power plants. So as we move to more solar and wind, we will need some of these battery storage things to really shed that peak hour of the peak day of the year. And for us, it's within ISO New England. So with that, thank you, and I will go ahead and stop sharing here.
Great. That was a very interesting, Paul. I appreciate all those updates. One thing you didn't hit on too, and I know that you've been looking at some electric vehicles just for operational use. Can you tell us, like, I know you've got some trucks and
Yeah, they weren't as aviation sexy, but they're
right.
still a great opportunity. So absolutely, we've got now 3 F-150 Lightnings that we're bringing into the fleet. Their load profile, again, it works pretty well for us because our vehicles are often from our operations vehicles to our maintenance vehicles, they're responding to issues, but then they're often parked for long periods of time. And the great thing about these is it's all electric, so even the heating and air conditioning, right? So if you have our PD vehicles, oftentimes you have to be in this position of idling. So there's no idling on these fleets, and the load profile again works pretty well for us because then they can be plugged in for the next shift, and then we can rotate them through. So we also have a couple electric vans now on that side. And in the future, for our remote parking facilities, we'll be looking to use electric shuttles as well, but not in the initial. Right now, they are all unleaded and diesel as they stand today.
Well, great. So thanks. It looks like we already have some questions for you, Paul. So
Excellent.
I'll dive right in. I see Bill Weber has his hand up.
Yeah, thank you, Paul. That was very inspiring, and I hope other businesses and airports follow your lead on this. But I want to just say that I think you're hitting the low-hanging fruit, and I think it's just going to get tougher from here on out. I was surprised to see, looking at the benchmarking report, that the Jetport has the highest greenhouse gas intensity of any building in the city. Ocean Gateway is 11.5, and the Jetport is 19.4. So that's something that I was surprised to see, given all the great work that you have been doing there. So I also wanted to ask, One Climate Future has an interim goal by 2030 to reduce greenhouse gases by 35%. And I guess I'm wondering whether you have a plan in order to meet that goal, especially if you're expanding, that makes it even tougher. So if you could just expand on that, I'd appreciate it.
Yeah, thank you, Bill. Those are really excellent questions. So one on the energy density, we kind of spoke to it, but I didn't speak to it. And the reason our building energy density is so high is because we're plugging airplanes into the building. People wouldn't realize that, but it's much better to plug the airplane into the building than to run at what we call, I showed the conditioned air, but there's another whole thing too. There's a 400 hertz ground power that we plug into the aircraft, and each one of our jetways currently already has that. So when the aircraft's at the gate, we can have 13, it's actually of our jetways now that have the ground power, it's 12. And all those planes are actually plugged into our building, adding to our electrical footprint. So it's not an apples, these things we kind of look at it and it's very hard. So it's oftentimes apples to oranges, unless you have somebody like me to explain it. But it's a good thing, right? Because we don't want that jet fuel powered auxiliary power unit spinning at the gate, nor do we want them plugged into a diesel ground power unit. So by having that higher electrical energy density of the building, we're actually reducing our emissions at the Jetport. And over time, as we continue to, Maine has a good, electric, we have a lot of renewable energy. So as we keep that moving, it will truly be awesome to have these planes plugged into a mostly renewable electric supply grid, renewable energy, electricity. So it's a win-win, but it doesn't look like it when you look at that base data. So now, and again, we can electrify the airport, but it won't, unless our supply chain in Maine is sustainable, we're not going to meet our challenge. But we're going, so this next project, that gates 3, 4, 5, and 6, by getting rid of that conditioned air, at least on our ground, it will significantly improve the amount of emissions we're doing on the apron. But what it will do is continue to make our terminal look like it has a higher energy density, because all of those will be plugged in to the electric heat pumps either in the building or attached to passenger boarding bridges. So that's that one. So how do we get there? There's a lot of work. So I should even speak to aircraft, right? Because that's the other thing, is that aircraft, people know that right now the energy density of batteries isn't good enough to work for aviation at this point. But there's a lot of work going on with SAF, sustainable aviation fuel. And I was working with Logan. They applied, and I was a partner on that, to start to look at the logistics of the production of sustainable aviation fuel in New England. Lots of attention to this. And in fact, one of the it's still being worked on, but one of the plants in Lincoln, former paper plants, the former Lincoln paper plant, is looking to start producing E100, which is a biodiesel, and at some point could be refined to a level of SAF. And what's really interesting, you can't even, it just came as a huge excitement for me, is that one of the byproducts of making E100 is potassium acetate and sodium formate, which are actually runway de-icing fluids. So not aircraft de-icing fluids, but runway de-icing fluids. So we're looking to partner with this new Lincoln E100 facility to start doing, to provide us with runway de-icing fluid instead of buying it and having it trucked in from far away. So it's funny how the tentacles of sustainability, these very positive things, are coming in many directions. And we do have a lot of waste bio in Maine that could help us solve a lot of the larger aviation carbon problems. And and I know there are many questions, so I want to be careful of doing it. One of the things that I also wanted to make note of is that aviation isn't as energy, aircraft aren't as energy dense as it seems. They get an equivalent of over 50 miles per gallon equivalent per passenger in aircraft, and people have no idea. So they're better than a car, they're better than a motorcycle, they're better than transit buses. They are not as good as rail. So very interesting. So if we can break the SAF code, and again, people will say, well, how is that possible that a plane is more efficient than my car? Again, it's because we can cram more people in an aluminum tube than any other form of transportation. So with that, thank you, Bill, for the question, and sorry I went so long.
But can we add on that a little bit? Because you talk about the side benefits of sustainability. I'm assuming there's some air quality improvements from using the Jetport as the power source for the planes and the air conditioning. Because I know a lot of times if I get off a plane, you smell jet fuel burning or diesel. How is that improving the operation or the health environment around the Jetport by transitioning to electric?
Oh, no question. I mean, and that was part of the original geothermal system, right? Is that it was a VALE grant, a voluntary airport low emissions grant. So instead of the airport burning number 2 fuel oil, we ended up using electricity. And again, Maine's, energy supply is much better than most of the country. And the heat pumps used for the geothermal are very efficient. So that reduced on airport emissions. So now, instead of having an engine on the apron, once we start to do this conditioned air to the building, that's diesel, or actually some of our conditioned air carts are actually just gasoline. So instead of those running, and many times it's a reciprocating engine with some heat recuperation, that all goes to that's emissions, or the heating is running off that APU I mentioned earlier. But they hate to run the APUs because those jet engines, it's a small jet engine built into the aircraft. They're just really expensive to operate and unnecessary. So the airlines hate to operate them, but they both produce combustion emissions. By plugging into the building, we're electrifying, right? So the more we as a state become, and even part of it is hydro from Canada, right? That base load, we really benefit from that, as well as it stops emissions on site and transfer them to electrification. And we're as good as our supply grid.
Cool. How about any more questions? If people, feel free to hop in or raise your hand if you want, or just if you want to just unmute and ask a question of Paul, that feel free. Lots of information here. I can ask a few questions myself if no one has any at hand.
I've got one, Troy.
Okay, go ahead.
What do you use for firefighting foam? Do you use aqueous firefighting foam on the airport?
Yes, so it's AFFF, and that's exactly right. It does have PFAS and PFOA. Airports across the country are required. You know, it's still in the Part 139 regulations. It's just a year ago that changed, that you could use a different, which is now called F3. It's fluorine-free foam. And actually, just earlier this week, the second manufacturer of fluorine-free foam was released, which is great. I'll stick with F3, which is the new trade name. So we do not spray it at this point unless it's our current trucks do have AFFF. Our current trucks are loaded. They have been, but they do not spray it. They would not release any unless there was an emergency. We now have a new air rescue truck on order that will, when it comes into service later this year, it will be F3. It will not have the PFAS or PFOA based AFFF. It's been a long road. Back when even 3 years ago, we were still required once a year to test it and spray it. We were capturing it and having it released and having it cleaned up by Clean Harbor. Even when we had a small, what has it been, 2 years ago, a small Cessna that had a hard landing, no fatalities, but a hard landing on our north-south runway a couple years ago. It was on fire. We did spray. Part of that was to boom and contain all of the, all after, you know, people are safe. And we had Clean Harbors come and clean it all up. So we do not release it at all now, even during an emergency event. There's an immediate post-action cleanup. But within the next 2 years, we will be changed out entirely to F3. Part of the problem of changing out our current, and again, thank you for this question. There's a lot of technical stuff here, and I don't want to bore people. You know, even the specs all came from the Department of Defense based on the ability to put out fires on aircraft carriers. I mean, that's where this comes, and then it has to be readopted, you know, all that comes, and then the commercial sector has to meet those requirements, and they have. The brilliant news is just earlier this week, we finally received our second F3 manufacturer that finally met the testing and is now available. So within 2 years, we will have no trucks that have AFFF. The problem right now is we don't know how to clean the current trucks. And the FAA says we will not fund replacement of a truck simply because it's contaminated with AFFF. But those standards for cleaning an existing, you know, aircraft, you know, firefighting truck is an aircraft firefighting truck is coming out, and we expect it within the next few years. But as of right now, the FAA is saying the states have to make that determination of what clean is, right? Because we don't want to take an AFFF truck, discharge it, have Clean Harbors or a reclaim an entity process and remove it, only to then contaminate the new F3. So challenging things here, but we do expect a standard to come and say, okay, flush it 3 times with water, all that water is contaminated. You have to pay for that as a hazardous material. And by the way, I believe EPA is on the cusp of designating AFFF. It's almost there, but they haven't done it yet. It is not yet a hazardous material, but I believe the designation is imminent, that AFFF will be designated a hazardous material.
Yeah.
But great question, and there are literally day-long seminars on that issue that you just raised in our industry.
Great. Thanks. So I see Ed has a hand up.
Yeah, Paul, it's great to see all of these things that we planned years ago coming to fruition. So great job getting them there. Quick
In
question.
part, thanks to your help, Ed.
Quick question though is, would you talk about a little bit about with your leadership on the Metro board, improving transit connections to the Jetport so that both travelers and employees have better options other than driving their car to the Jetport?
Yeah, so the new schedule is coming, Ed, and you're more familiar with me, but we did change up the 5. It's going to be more frequent, and I should let you mention the actual schedule, Ed, because you were on the ridership committee, so you know exactly what's coming. But it's been great. It has been a challenge because we start so early, and the frequency has been a challenge. So for instance, right now, our employees are arriving at the Jetport at 3 a.m. to be prepared for that 5:20 departure. But what is critical is that many things have happened with Metro. We've gone, we went from diesel to a mixed CNG fleet to now a partially electrified fleet with more options for that in the future, which is exceptional. And now, as we've made a change on the Route 5 and the Husky line, we're going to be able to offer, it's on the half hour now, right, Ed? And an earlier start of operations. Yeah, to service us. So what that does is really gets the local, arrival person. People can, if your flight is, I believe it's 7 a.m. start now. Is that right on, Ed? Or will be very soon. The change is happening very soon. Do you know what date it's actually happening, Ed?
I don't remember the exact date, but yeah, we're expanding the frequency and the range from start time to a later ending time at night.
So all within the metro region will be able to get to the airport much easier on a half-hour turn during the period of operation, which is brilliant. And we really appreciate, because I know we've mentioned, and I didn't want to spotlight it on this, but we are having parking challenges because we serve a very large rural state, and many of our passengers are not coming from Greater Portland. They're coming all the way from the Canada Maritimes and the upper parts of the state and into North Conway in that part of New Hampshire. And there is no public transit yet. So what I've said time and time again is that the way you really have to have that parking capacity at your multimodal hubs, because you don't want the pickup and drop offs to happen, and you want them to be able to come, park, and just leave that vehicle shut off for the duration, and then when their passenger arrives back, they have their vehicle here, and then they can go. But pickup and drop-offs tend to be less efficient, and they're kind of like on demand, more of an on demand. And when that vehicle is returning to wherever it came from, it's less efficient. And than just having the parking at your multimodal facility, of which the airport and the train station and the bus stations are. So that's what we're trying to support when it comes to the parking equation.
So, Paul, can you, I know you've mentioned in the past that the way people are parking is changing post-pandemic. Can you explain a little bit more about that? Are we seeing cars stay longer than they used to, or?
Yeah, we've gone from like the duration of parking has gone from roughly 3 days, 20 hours to more than 4 days, to just 4 days and a certain amount of hours. So it's a pretty good percentage. It's over 9% increase in the dwell time of our average parker. And we can look at many different reasons post-pandemic, but the one that we really have seen is that many people can now work remotely and do a lot of their business remotely. So when they get to their destination, they're staying there longer. And it's increased the duration of travel. And maybe those shorter trips that used to happen for business and other are now happening with Zoom, but it's only the longer trips that we're moving ourselves to that location. So perhaps, what used to be a quick day trip or day and a half trip for a business traveler is not happening now. They're just doing those on Zoom. So instead, it's the 2-day trip that the business traveler. So our business duration is longer, and our leisure duration is longer. And there's this I guess what they're labeling it as business leisure travel is longer, because they do their business trip and then they stay even longer for leisure because they can work remotely. So we're still trying to delve down into it, but that's part of the issue with our parking accumulation. And at least for now, we think the best way is to accommodate on site and not to run a lot of shuttles, but to make it walkable distance to the terminal to the maximum extent possible. And that will mean in the future additional high density parking garages that may ultimately change to something else. We know that many entities now are doing higher capacity stress. People wouldn't think of it, but parking garages aren't stressed to be office buildings, but they're doing that in the future, because a parking garage is really only 30 to 50 pounds per square foot of load capacity, whereas your major commercial buildings are 100 pounds per square foot load capacity because of the density you need for means of egress in a commercial building. Those quarters are all, what people don't realize is a dense exit quarter is much more stress loaded than even a big electric F-150 sitting on the floor of that's 20 by 8.5 feet wide. So it's not as much stress on these garages. So to design them for future use, you can do that when you're designing a structure, and people are now.
And speaking of parking, I know you have some EV charging. Is that something you're looking to add more of?
Yes, we do. We've it's really just the initial, but when we're even on this current parking program, we're looking, Portland's new new code is that you have cabling for 50% of spaces, and then you have plugins for 20. I believe it's 20%. And Troy, don't hesitate to correct me if I'm wrong on that one. So this is the under our current code. So with this new program, with this new parking we're looking to add even more charging in the structured parking. But there are challenges. We are seeing some concerns with the energy density of batteries and where to place those in parking garages. But right now we're basically in the single numbers, but we'll be talking after, as part of this next parking project that will have up to 300 electric spaces. So we're looking to where those would be located. And right now we believe, in talking with designers, that the electric spaces should be on the perimeter of garages so that they're on the open air. They're accessible in open air, and you can dissipate the heat if one were to catch on fire. If one of these lithium ion batteries were to catch on fire, they dissipate heat, even though technically it's easier to put them in the center oftentimes, because that's an easier location to feed your power supply. But right now we don't recommend that. It's keep them to the perimeter, and then have sections with do like 20 cars, then have a break and another 20 car electric parking spaces. The downside on the 20% is that we're still not there yet. We're about, I think, 3% in Maine. Troy, correct me if there's better data, but we want to be really careful because we like to mark our EV spaces as EV only. But as we roll out our new parking, we can't do that, because if there's only 3% of parkers are electric, we'll designate 3%, or more percent. We'll make sure there's always enough available as we start to roll out this new parking project. But we want to be very careful that we're not building more spaces than are needed because we're designating 20% of spaces electric. There'll be 20% of spaces that are already wired for electric, but we won't necessarily require them to be electric vehicles parking in them, because we don't want to overbuild our parking when and have empty spaces that could be used by a non-EV vehicle. So there are still some challenges out there that we're working through. And one of the challenges on EV vehicles that I did resolve is some of these new, like the new Hummer and the new Silverado, they're like 9,000 pounds. So we even had structural concerns for the parking garages if you were to fill them up with these. But as we reviewed it, it's not an issue. The structural is not an issue. The big issue today is the possibility of an uncontrolled fire. And it's very rare, but if one of these were, it's a challenge. And we want to make sure we design around that. Certainly for the surface parking outdoors, we're not overly concerned, but even with those, we will probably keep, do some level of break in the number of charging stations. We don't want to just do 100 in a row.
Well, Bill has another question.
Yeah, sticking with the parking. I know when I've returned from trips, usually at the end of the day, and I'm dead tired, I'm always grateful that I can find my car in the garage rather than having to shovel it out. So what is preventing the Jetport from going directly to a garage rather than open parking at this point?
Yeah, great question. So the next phase of the parking garage is on top of existing surface parking. So, within our master plan, we called for, basically everything south of Jetport Boulevard ultimately becomes a designated parking. It's within the airport business zone. And by doing the surface parking next, it allows us the wiggle room to then build the next phase of structured parking is the challenge. And there's a whole discussion on that I can show. And again, the demand came faster than what our plans would have expected due to the pandemic. So that's the challenge. If we were to jump in, it's just there's no room to build the garage now. And ultimately, in our master plan, we call for this all to become parking, south of that Jetport Boulevard. And the other part of the equation is there was a former parking operator, Park and Jet, that we purchased their land just north of the parking garage. And there was never any investment in that lot. It's just a big gravel, space. It's just a big gravel lot. And we need to get in there and get stormwater drainage and treatment. Because what's happening right now is that gravel, when it rains, it wasn't our site, and it was permitted before there were the requirements we have today for pre-treatment of surface stormwater. So we need to get in there as part of this surface parking project and get all that fixed and up to standard.
Paul, was there thought about pushing the rental cars off-site?
So right now, all but one are on their actual space, where they do their car washing and fueling and all of that is in their own space. All we have of them on site is just 230 spaces. And that's the spaces that people return and pick up at. It's not their holding lots or their wash and fueling stations. Just the space. And we, again, to move that off-site becomes another shuttling for all those passengers that arrive in baggage claim and right now can just walk to the rental car space. That would force, instead of walking now, it would be a whole shuttle operation. So as long as that is, at some point it will be, the shuttles will all be electric. But again, it's, just a quick walk is a lot more efficient than running shuttles. It's a lot greener than running shuttles. So if you can keep the car rental facility within walking distance of the terminal, we want to do that and support that as long as possible. And we don't have, thankfully, we aren't Logan yet. We have enough space, even though we are very tight, we have enough space to keep from operating shuttles essentially almost, it's not 24/7, but it's 20 hours a day. And that's a lot of time to be running shuttles. And if I were to show you, maybe I can here just quickly, just do a share screen. And I'll do it, where's my share again? Share screen. And I'll jump back to this presentation again. It's another slide that I'll do a reading view here. And hopefully, can you see that, Troy? Okay.
We see an average.
Yeah.
Yeah.
So what I wanted to show here is this is this was the old one, and I'll show you the new one next. So when we run a shuttle, this is transit buses that I'm showing right here. And let me jump down to the next one because this is actually a slightly outdated. So I'm going to jump to the next one. This is the newer one. So I kind of spoke to this. So airlines are an airplane right now, average fleet for the US, which I said crammed a lot of people into a plane, is 53.62 miles per gallon equivalent. A brilliant rail like, Metro North and stuff now is up because they're back to full again. That earlier chart was, right after the pandemic, which they weren't full. So they're up to 141 miles per gallon per passenger equivalent. You go down to a transit bus, it's down at 26. And if we run a shuttle bus, it's even less because we have to run them all day long, essentially, or 20 hours a day, but they're not full. But we have to be running and have these shuttles moving. So if we're walking, and it's the same for parking shuttles, right? You're running on a headway of 15 minutes, regardless of how many passengers are on the shuttle. Even if there's 0, you're still running because you have to run the shuttle service. So it is not, running shuttles is not green. So to the extent we can have, and I'll stop sharing again. So to the extent we can have density on site of our parking and our operations so that, and we can maintain walkable distance, it saves our carbon footprint. Even if there are electric shuttles, you still have to manufacture the shuttle. And if we can just have people walk to their parking and walk to the car rental facility, way better than remote in terms of the footprint that we're doing for that shuttle operation. So I know that some may not recognize that, but that's the reason we're trying to do, instead of, you could call it airport sprawl, we want to do airport density.
Great. Let's see. Anyone else have another question? We're getting we have time for 1 or 2 more if people have them.
And I just want to apologize. Awesome questions, and I apologize. There some of these, each question you could really spend. You could do a whole PowerPoint presentation on most every one of these questions because they're so informed.
I know. Well, that's one of the. I always enjoy talking with you, Paul, because you're really, you can tell you're really passionate about the subject and you're really well informed, and I really appreciate that. So with a short time left, is there anything that we haven't talked about yet that you think we should know about, or any what question you wish someone had asked, or?
The challenge, I mean, is I think the real challenge for the industry, and I didn't go into this, but there are things coming, right? It's not working today. So we had Cape Air flying out of Portland, and they fly in, currently they mostly use a Cessna, is what a twin engine Cessna, very small plane, right? With just, I think, 9 passengers. And they've switched over to a new Italian plane that was hoping to go electric. But we're waiting. We can see there's a day coming where there will be advanced air mobility, and may even be the vertical, what we call the AVTOL, advanced vertical takeoff and landing, and they may be without a pilot, right? So there's a lot of really awesome stuff coming down the pike with technology that will start to electrify aviation. It's just where we're challenged right now is the energy density of batteries. So where I was going there is that the Cape Air, they thought they might have those smaller electric aircraft sooner, but they had to scrap it because of battery technology right now. But it is coming. And there is a lot of momentum on SAF, which is directly replaceable and blendable with jet fuel, which is, jet fuel isn't technical, it's just kerosene. So there's a lot of opportunity in over the next decade. And I know we're up with these challenges. Who thought 2030 isn't far away now? When we were talking 2030, 2035, and 2040, it seemed like forever. But wow, 6 years. All these things we were talking about just a few years ago on the architectural and engineering front, 2030 is coming fast. And I will say there is a lot of energy. So that study I was working on with Logan, It's looking at the logistics of getting SAF to Logan, which is the big user, and then being able to, once it's dispersed to Logan, getting it to us. But who knows? One of these bio plants that used to be a pulp, a paper plant in Maine, could be sending, be a reasonable production source for us in not that distant a future, which is incredible. So I didn't even touch upon all of the advanced air mobility, all the electrification of vertical takeoff and landing, the possibility of all that, and but it is very exciting.
Yeah. Well, it's great. We're all going to be looking forward to that. We really appreciate your time and the update on all the different measures you've been taking at the Jetport over the years. So again, thanks a lot for participating, and just about at time. So we'll wrap it up until next month, and we hope we will see you all then. Have a great weekend, everybody.
Thank you.
Thank you, Paul.